Hey everybody, this is 5.5. So for 5.5, I kind of save these word problems for the end. This is from 5.4. So if you look at the last page of 5.4, you'll be able to find these examples, okay? So I'm going to go over a couple examples of these, and then in the actual 5.5 notes, there are just some, it's like a practice quiz. So I'm going to go over those, but if you would, maybe pause and give those a try. Let's go from there, okay? So first off, we're trying to solve these types of problems. Your answers, your problems will look a lot like what we've done in the past, okay? So you're going to, once you get the equation, you're going to need to come up with a common denominator and then solve for x, just like we did before, okay? So let's get into it. So Tom can paint a certain room in 6 hours, but Jerry needs 4 hours to paint the same room. How long does it take them to paint the room if they work together? Okay, so all these problems have to do, at least the majority of these problems have to do with this little equation, okay? Distance is equal to rate times time. So for these problems, you're going to be able to come up with two of the three things, and we're going to use that to come up with our final equation, okay? So let's just fill in what we do have. So Tom can paint a certain room in 6 hours. So again, 6 hours is our time. It takes him 6 hours to complete a room when he paints. So distance, again, distance is going to be like anything that we're trying to accomplish. So distance could be like somebody running, okay? But it could also be like mowing a lawn or painting a room, okay? So all those things could be kind of like our distance, what we're trying to accomplish, okay? So he wants to paint one room, okay? Jerry can do it in 4 hours for the same room, okay? And we want to know what happens if they do it together, okay? So together, again, we're doing one room, but we don't know how long it would take him, okay? So the only thing that we're missing here for all of these, for Tom and Jerry, and together, is the rate, which means that we could divide both sides, like we could make this be little equations. This would be rate, 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 okay? And we could solve for rate. We could divide both sides by 6 hours or 4 hours or x, and that would give us our rate, okay? So by himself, the rate for Tom plus the rate for Jerry should be equal to the rate of them together. And we know all of those things. So the rate for Tom, again, we would need to divide both sides by 6, and we would get 1 over 6. So that's our rate. So again, a rate is kind of like miles per hour or dollars per hour, things like this. This is rooms per hour, okay? And then we're going to add the rate for Jerry. Again, we can solve for the rate, and we would get 1 over 4 is equal to the rate together. Again, we could solve for the rate, and we would get 1 over x. Okay, so that is how we can kind of come up with our equation. From there on, it's the same as what we did before in 5.4, okay? So we are going to need to have a common denominator. So this has an x, but the other two do not. So we would need to multiply x and x, top and bottom. Okay. Let's look at the numbers. So again, we could do like 4 and 6 and get 24, right? But if you want to try and simplify a little bit, we could say, well, what is the smallest number that 6 and 4 can go into? And that would be 12. So we can think about what do we need to multiply to give us 12. So here we would need to multiply this by 2, top and bottom. We would need to multiply this by 3, top and bottom. And we'd have to multiply the right side by 12, top and bottom. Okay? So again, if it's an equation, like we have, maybe I'll write this out. So we'll have 2x over 12x plus 3x over 12x equals 12 over 12x. So again, if it's an equation, then we could do anything we want to both sides. We could multiply both sides by 12x. And these would all cancel. And then we just have this smaller equation that we could solve for. So 2x plus 3x is equal to 12. Combine like terms. And then divide. So we'd get x equals 12/5. Okay. On the homework for these types of problems, it will accept fraction. If it can simplify like nicely into a nice decimal, then we could do that. So for this one would be 2.4. Okay, so both of those would be okay. I know sometimes on some of the other problems when we get a fraction, if we put a decimal, it wouldn't accept it. So if you're worried, you could just always just do a reduced fraction, and that will always be fine. Okay. All right. For B and C, these are a little different. If you want to kind of go through that, I have it filled in on the notes, but I just want to kind of stay, because these ones aren't so much like distance equals rate times time. And I think most of the ones that you'll run into, if all of them, are more like the one we just did. Okay, so let's look at one more. So I kind of added this here. If you want to write that down, you're welcome to. Okay, but it's the same sort of thing. Again, it's distance equals rate times time. So a woman can bicycle 84 miles. Okay, so 84 miles would be our distance, and we are doing bicycle. So B for bicycle. So here we would have 84 is our distance for bicycling. At the same time, it takes her to walk 24 miles. So W for walking. This person, this woman, walks 24 miles. Okay. It says she can ride 10 miles per hour faster than she can. Just come back in a minute. Thanks. 10 miles per hour faster than she can walk. So for walking, again, that's a rate. Miles per hour is a rate. So for walking, we're just going to say it's some amount. We're not sure what that is, but we know that when she rides the bike, she can do whatever that same rate is plus 10. Does that kind of make sense? So we have all of that information. We don't know what time is, okay, but we still have this little equation, which means that we could solve for time, and which is helpful because it tells us that she travels 84 miles in the same amount of time it takes her to walk. So both of them, they have the same time. So the time for bicycling is the same as the time for walking. So we can just solve for those things. So for the time for bicycling, that is just going to be 84 over x plus 10. And then for the time for walking is going to be 24 over x. Okay, so this is a little different. We're not like adding things together. There's not two people. We're not trying to combine them together to see how fast it takes. It's kind of comparing walking versus bicycling. Okay, so that's our little equation. Hopefully that kind of makes sense. Again, you're welcome to come in and talk to me about it, but let's finish it up. So we need to have a common denominator. So let's maybe look here. We have an x, but we don't have an x here. We have an x plus 10. So we would need to multiply top and bottom by x. And then let's look at the x plus 10. We don't have one of those on this side. So we would need to multiply top and bottom by x plus 10. Okay, so again, if it's an equation, we could multiply both sides by the denominator and cancel them all out since they're the same. Okay, so those will end up being gone. So we'll get 84x is equal to 24x plus 240. Again, we're just distributing to get rid of our parenthesis. Okay, so then we're almost done. We just need to subtract 24x. So we would end up getting 60x equals 240. And then the last thing we would need to do is to divide both sides by 60. Okay, so we'd end up getting x equals 4. Okay, so she can walk 4 miles per hour. Sorry, miles per hour. Okay, if we wanted to know how fast she could bike, well then we could use this, and we could plug in 4, and we'd end up getting 14 miles per hour. Okay. All right, so that's our answer. Again, we could also talk about excluded values. So x can't be 0 and x can't be negative 10. But, I mean, if you really think about it, x is our rate. So we can't have a rate of 0 anyways, right? And we can't have a rate of negative 10. You can't have negative rates. Okay? All right, so, okay, so that's it. If you feel like you're good, you could probably go and just be working on your homework. But again, I'm going to go over these examples, just a quick reminder. So on your homework, you're going to find these types of problems, and it goes over the previous lessons. So just in case you've forgotten already, you could go through this. Again, I'd encourage you to pause and try this on your own and see what you can come up with. Okay, so first off, always check for factoring. Okay, so again, it could be a GCF, like what you could divide the terms by and pull that out, or it could be the puzzle, factor by grouping, where we do what multiplies and adds to. Okay, so for this one, nothing can be factored up here, nothing could be factored down there, but here we do have a GCF. We could look at 8 and 32, and it looks like we could factor out an 8. So we could take out an 8, and we would get x plus 4, okay, which is helpful because now we can cancel out that x plus 4 top and bottom, okay? We can also simplify our coefficients here. Again, what could we divide 2 and 4 by? Well, we could divide them both by 2. So this could give us 1, and this would give us 2. Okay, so now we can just multiply across. So 1 times 8 would just give us 8. And I think all we have on the bottom is 2. So here we'd end up getting 4. And our excluded values, x cannot be negative 4. Okay. All right, let's try the next one. Again, this needs to be factored. So the top is a quadratic and the bottom is a quadratic. So the top is factoring by grouping, where we do the puzzle, what multiplies to 20 and adds to 9. Okay, so I think that could be 4 and 5. So x plus 4. And x plus 5. And on the bottom, it's the difference, meaning subtraction, the difference of squares. So this is x squared, and this is 5 squared. Okay, so then we would have x plus 5 and x minus 5. Okay, we want to see if there's anything we can cancel out. Looks like we can cancel out these x plus 5s. So our answer would be x plus 4. And we don't need to have the parenthesis if there's not something outside of those parentheses. So that's our answer. And then excluded values, x cannot be -5 or 5. Again, that just comes by, we could set those equal to 0 and we could solve those individually. Okay. All right, let's look at C. Again, check for greatest common factor first, and then see if you can factor by grouping the puzzle, right? So here it looks like we could factor out a 2x on top, so 2x. And then if we divide everything by 2x, we would get x minus 5. Okay, and on the denominator, again, it looks like we could take out an x, so 4x squared minus 25, and that is the difference of squares. So again, this is 2 squared and x squared and 5 squared. So that means we would have x, 2x minus 5 and 2x plus 5. Okay, so that's all just simplified, and then we want to see what we could cancel out. So maybe I'll write this out so it's not all over the place. Oops, sorry. Okay, so 2x minus 5 and 2x plus 5. Okay, so I think the only thing we can cancel here, if I did this correctly, let me just double check really quick. Yeah, I think that's right. I don't know that I was anticipating that. My guess is I probably didn't mean to have that 4 there, but we'll go for it. I think it's still okay. So these would cancel, and then everything else would still be the same. Okay, so 2x minus 5, and then 2x minus 5, and 2x plus 5. Okay, if there wasn't a 4 there, then we should have been able to cancel the x minus 5. So just in case I meant to do that I did that on accident. Okay, and then excluded values, again, x cannot be 0, 5/2, or -5/2. Again, we just set those equal to 0. Here would subtract 5, and then we'd have to divide both sides by 2. And that gives us that. Okay, similarly with the 5/2. Okay, all right, here we go. Next one, factoring. Okay, so there's no GCFs. So we will find what we multiply to 2 or 4 and add to -5. So x minus 4 and x minus 1. And on the denominator, this would be multiplies to -20 and adds to -1. 5 and 4, so -5 and a +4. Again, now it's division instead of multiplication, so we want to change, flip. So we're going to change this to be a multiplication, and then we are going to flip the fraction. So we would end up getting x minus 5 and x minus 4 on the bottom. Okay, so then we could see if we can cancel anything. So canceling, we have x minus 4 and x minus 4. We have x minus 5 and x minus 5. So all we have left is x minus 1 over x plus 4. And then excluded values, x cannot be, there's lots of things here, it can't be 5 from here, can't be -4 from here, and it can't be, it can't be +4 from here. Okay? All right, we're almost there. Just a few more. adding. So again, adding, we have to have a common denominator. This one already has a common denominator, so we are just going to add their numerators. So we'll have x minus 1 on bottom. We have 4x, but there's no other x terms on top. And then we will add those together, would give us 0. So this would be our answer. Excluded values, x cannot be 1. Okay. Here's another subtracting. This is one where a lot of people run into mistakes, okay? So pay attention here. We have a common denominator, so then we're going to subtract. So 7x subtract 5x would give us 2x, and then we're doing 2 subtract 15. Okay, so it's that part that people will forget. They'll do 2 plus 15, but it's 2 subtract 15. So negative 13. Okay, so I think that's our answer. We can't factor and we can't cancel, so our excluded values would be negative 10. Okay, also I've had people, since we talked about solving, people have tried to cancel, right? We only cancel if we can multiply both sides. And this isn't an equation, so it's not like this where you could multiply both sides, okay? All right, last two. This is solving, so we need to have a common denominator, and we will be able to cancel by multiplying both sides by the denominator, okay? So here we've got an x plus 1, but we don't have one on this side. Okay? We cannot repeat, we cannot just like subtract 1 and subtract 1, okay? That does not work out. Okay, we have to do their opposites. And this is division, so the opposite is multiplying. So we would need to multiply top and bottom, okay? And on the left side, similarly, we would need to do x plus 2. Okay? Now we have a common denominator. We could multiply both sides by that. Keeps it balanced as long as we do it to both sides. So we'll have 5x plus 10 by just distributing, and then distribute to give us 2x plus 2. Okay, get all the x's on one side, and get all the constants on the other. So we'd get 3x equals negative 8, and then we would divide both sides by 3. So that would be our answer. Make sure you simplify, if possible, reduce that fraction. Okay, this one can't. And then our excluded values would be 1. Nope, negative 1 and negative 2. Okay. All right, last example. Again, we need a common denominator. This has a denominator of that, but the right side doesn't have that. So we could multiply top and bottom by 4x plus 7. Well, that was not great. Now we have a common denominator. We could multiply both sides by that, and it would cancel. So we'd get 9x equals 4x plus 7. Subtract 4x. So 5x equals 7, and then we could divide both sides by 5. So that would be our answer. Can't reduce that fraction, but if you could, do it. And then excluded values. Again, this one's a little trickier because we have a coefficient, but I would just set it equal to 0. We could subtract 7, and then we could divide both sides by 4. Okay, and that would give us negative 7/4. All right, well, if you have any other questions, this we'll just probably talk about that briefly when we get to 5.6. So don't worry about that so much. Okay, all right, we will see you later. Let me know if you have any questions.